Today we're going to discuss the concept of limiting reactants and excess reactants and how to apply them in stoichiometry. First, some definitions. A limiting reactant is the reactant that gets used up or depleted first. In doing so, it limits the amount of the product that is formed. That's why it's called the limiting reactant, because the reaction stops when the reactant is used up. So if you remember, in our recent reactions lab, we had ethyl alcohol in a watch glass and you lit it on fire. And the ethyl alcohol ran out first. There was still plenty of oxygen in the air. And so the ethyl alcohol would have been the limiting reactant in that particular reaction. The excess reactant, in this case it would have been the oxygen, is the reactant that's left over when the reaction stops. So one of the important things you have to learn how to do is how to identify the limiting reactant. So let's go back to my favorite reaction, making ammonia from nitrogen and hydrogen gas. If you have 1 mole of nitrogen and 3 moles of hydrogen, then they're both going to get used up. That's in the proper ratio, proper stoichiometric ratio, and neither one is limiting. And that would be the same case if you had 2 and 6 or 3 and 9 or any ratio that has 1 mole of nitrogen to 3 moles of hydrogen. But if the mole amounts are different and you don't recognize the ratio, then what you're going to have to do is compare what I call the mole equivalence. So start with a reaction, a little different, the same reaction but a little different numbers. We have 1 mole of nitrogen and 2 moles of hydrogen now. The way we're going to find the mole equivalence, the way we're going to identify the limiting reactant, is by dividing the actual moles by the moles in the coefficient. So when I say the actual moles, we're going to take the 1 mole of nitrogen here and put it here. And then we're going to take the 1 mole, that implied 1 mole here, and divide by the coefficient moles. In this case, they happen to be the same, and it gets us 1 as our ratio. For hydrogen, we'll do the same thing. We'll take the 2 moles of hydrogen that we're given, and we'll divide by 2. Oh, sorry, we'll put the 2 there. Then we're going to take the 3 moles of hydrogen here, and that's what's going to go in the denominator. And we get 0.67 as our mole equivalent for the hydrogen. Now, since 0.67 is less than 1, 0.67 is less than 1, the 0.67 gets used up first, the hydrogen gets used up first. And so it's going to be the limiting reactant in this particular case. Let's look at another problem. Slightly harder because now we have slightly different numbers of moles. So now we have 2.3 moles of nitrogen and 7.6 moles of hydrogen. This is going to be a little harder to look at because you really can't see the ratio here without trying. So the mole equivalent of nitrogen, again, we're going to take the 2.3 moles here and put it in the numerator. This 1 mole came from the balanced chemical equation. For hydrogen, we're going to take our 7.6 moles of the hydrogen and divide that by the 3 moles of hydrogen in the balanced chemical equation. In this case now the 2.3 mole equivalence of nitrogen is lower, and so the nitrogen is going to be the limiting reactant in this particular case. It gets used up first, and it will control, as all limiting reactants do, it will control all the rest of the stoichiometry that goes on with this reaction. Let's look at a mass-mass problem, because most of the time we are going to be using mass instead of moles. We give mass instead of moles. Don't always assume that the smallest number is going to be the limiting reactant, because it all depends on both the molar mass and it also depends on the molar ratio. So if you're giving mass, the first thing you have to do is determine the number of moles of each reactant using the molar mass. So the number of moles of hydrogen, take the 10 grams, multiply by 1 over the molar mass to get the number of moles. Hopefully this is very familiar and doesn't need any further explanation. Nitrogen, the same thing. Take the 20 grams of nitrogen, multiply by 1 over the molar mass, and we have the number of moles of nitrogen. Now we go back to the same thing we had just done. We'll determine the mole equivalence as before. we'll take the 0.714 moles of nitrogen first, put that there, divide by the 1 mole of nitrogen from the balanced chemical equation, and we get 0.714 is the mole equivalent for nitrogen. For the hydrogen, we're going to take the 4.96 moles of hydrogen, divide by the 3 moles of hydrogen, and we get 1.65 mole equivalents of hydrogen. So you see, even though the hydrogen had a smaller mass, the mole equivalents of nitrogen are smaller, 0.714. And so nitrogen is the limiting reactant in this situation. Okay, your turn. I give you this new reaction, 4 iron 2 sulfides and 7 oxygen gas. This is a combustion reaction, even though there's no carbon or hydrogen there. 2 Fe2O3 and 4 SO2. What is limiting reactant with those amounts of FeS and O2? I'm going to pause the video and then start it up again when you're done. And we're back. Let's see how you did. Take the 84.9 grams of FeS, divide it by the molar mass of the FeS, and you get 0.966 moles. 64.9 grams of oxygen gives 2.03 moles of oxygen. Let's determine the mole equivalents. Take the 0.966 moles of the FeS and divide it by 4 moles of FeS from the balanced chemical equation. So we take the 0.966 moles of the FeS here, the 4 moles from the balanced chemical equation goes here. For the oxygen, we'll take the 2.03 moles, divide by the 7 moles in the balanced chemical equation. 0.242 is less than 0.290, and so the FeS is the limiting reactant. So at this point, you're going to continue going on. You're going to go and watch the next video on excess reactant and the amount of product produced. So continue with that, and then we'll see you in class.